this is John K. How you doing? Just wanted to show you what the work I'm doing on the solar charger. It's about 4 o'clock on a Saturday afternoon in Melbourne. I'm running off this 200 watt 24 volt solar panel. The sun's way off up there, so it's nowhere near perpendicular. It's kind of a cloudy slash sunny day, but let's see if we can show you something I'm doing with the charger. So at the moment I'm just loading this battery down with this 55 watt headlight. Here's the battery. It's a 450 cca car battery, so we're pulling about 5 amps out of it at the moment. It's been loading for a couple of minutes, so we're going to show you a picture of the switch. And I've modified this switch bit a little bit with this digital chip that I'm using to do all the timing. I've got a try and get the glare off that. There you go. I've got a DC voltmeter that's on the panel, so you can see the panel open circuit voltage is over 30 volts. This is going to show us the input current. This is going to show us the output current into the battery. So I'm going to hook this up. I'm just going to switch the oscillator on. Okay, disconnect my load, and let's have a look at what the battery's doing. Okay, so the sun's not fully out, but you can see that the battery is charging. You can see the voltage coming off the panel. The input current is about 1.5 amps, and this is the output. So you can see pulses of around 5 to 6 amps going into the battery. Okay, you get both meters in the shot there. So it's up to about 2 amps. As I said, late afternoon sun. This works really well in low light because it gets everything it can out of the solar panel, puts it through the Tesla switch, and then slams it into the battery. So we have a look at the battery now. You know, it's just about up to 13 volts. Okay. Okay, now the sun's just come out a little bit. You can probably see out the door there. Now our voltage is up to 3, and you can see what's going into the battery. Okay, sorry about the glare. Okay. And the sun's just hiding behind the clouds again, so you'll see it drop off. Okay, well, thanks for watching, and I'm going to post this up to the Energy Science Forum, and you can ask me questions about it. I can't post a schematic of the circuit at this stage, but you can see what it does. So just one more look there. We're just getting about 3 amps out of the panel, about 7 amps into the battery. That's our panel voltage, that's our battery. Thanks for watching, have a nice day. Hey, I just wanted to add, it's really gone kind of dark outside now, it's probably going to rain, so you can see I'm only getting an amp off the panel, but you can see what it's putting into the battery. It's just, you know, almighty, about 5 amps. So anyway, I thought I'd show you that. Cheers. Okay, so I wanted to add one more thing, get all 3 meters in shot here. You can see the input current there is about half of 1 amp. Okay, you can see the voltage on the panel. It's pretty much sun gone down, late afternoon, but look at what it's putting into the battery. This is what I wanted it to do. I wanted to capture all the energy that's coming out of that panel. And normally with half an amp you can't do much with that at all. It's not going to do anything to a decent sized battery. So what I want to do is capture all that energy and then smack it to the battery. So you can see when that pulses, you can see the battery just jumps up like that. And that's what I wanted to capture, that this thing really works well in low light. It really gets all the energy it can. It's like ringing the panel dry of energy, just sucking it all up and capturing it and then smacking it to the battery. Thanks for watching. Cheers. Okay, one more thing. So it's almost dark outside. I'm not far from darker. And we still see we get some voltage on the panel. If you look at the amps coming off the panel, it's maybe 200 milliamps, if that. But the way this thing is configured to track the sun and to get the most out of the panel, you can still see 5 amp pulses hitting this battery. You can see the battery's jumped right up. So this is what getting all the energy out of the panel means to me. So you can see this. You couldn't hardly drive a fly up the wall. The amount of current that's coming off the panel it's almost zero, but we're still able to capture all that and then send that to the battery. So thanks for watching. I want to show you this real quick. So now it's the next Saturday morning, around about midday. We've got full sun on the panel now, so you can see that's the current coming off the panel, between 4 and 6 amps. That's what's hitting the battery, almost 10 amp pulses, probably more. You can see the panel voltage is peaked right off the scale. And this is the battery. This thing is very badly sulfated. It's a 75 amp hour deep cycle, and keep the glare off it. You can see that's what it's doing to the battery. Okay. Thanks for watching.